A huge thanks to Brian for sponsoring this video. Good morning, fellow mathematicians. Welcome back to another video. Before you asked down there in the comments, yes, I have injured my hand. It happened in my wood shop and it's a dangerous job. I'm glad my hand is still there and I can still use it. So all is good. Do not worry about me. Today, I'm going to cover something that I haven't covered much of yet here on this channel in my years on YouTube, namely stochastics, a bit of probabilities. It's about constructing yourselves a little gambly game, and it's a pretty fun exercise. It's one from my recent exam in 13th grade, and I hope you are going to enjoy what you are going to see today. Definitely make sure to watch to the end of the video. Also because this video has been sponsored by the wonderful people over on Brin. They offer a great service. Keep watching and hear me out. It's some good stuff. Now, here's the exercise. Just imagine that your name is, I don't know, just a random arbitrary name, Jimmy Donaldson, for example, and you run an illegal lottery. And the nice person that you are, you want the illegal lottery to have a few rules attached to it. You are going to see at the end of the video that rules are actually not too bad. For the player, not for the person constructing the game actually. Now, here are the main rules. The game is as follows. It's in 2 stages. You are going to roll a die 2 times, and the die is a 4-sided die. It's a D4. You can number it however you wish. With the numbers from 1 to 4, you can use numbers multiple times. You can, for example, put 4 times the number 1 on there. Really doesn't matter. Now, one of the nut rules is that you always need to pay $1 to get started into the game. So there's something that you need to pay as a player to actually get started with the game. And then there are 3 rules. Now, the first rule is going to be that the sum of the numbers on the die must add up to 7 exactly. That's the first rule. The second rule is that the probability of rolling the sum of the numbers as a 5 is going to be 1/8. So the probability of rolling a 5 overall is 1/8. And the last rule is that you are going to expect the player to win $2 in the long run per game. It's an expectation value, basically. Those are the main rules. And those rules need to be abided by all 3 at the same time with the 4-sided die, the D4, that you can number however you wish. And you can see the rules somewhere here on the screen at all times. And I'm going to start writing over here such that you can follow along. Now, you need to be a bit tactical here when you go about it. You can't just start, for example, with the expectation value, because then you have so many millions and infinitely many ways you could go by. You couldn't reconstruct yourself the game nicely. So you need to go about it with the other 2 restrictions in some kind of way. Now, the smartest thing would be to actually start off with numbering the die in such a way that the sum of the faces is going to add up to 7 overall. And there are only few certain ways, because you can only use the numbers 1 through 4, and you need to number all the sides. Now, which combination is there for us to add it up and to get 7 overall? Well, for example, you can have 4. Let's start with the highest number. If you were to have a 2, for example, then you would have 6 and you need 2 more sides. This doesn't work out. So the only thing you can do is put 3 ones on here. So this is one of the possible dice that you can get, but there are a few more. Now, 4, there are no other choices. What about 3? So if you use 3, for example, you can't use another 3 because then you would overshoot on the 7. Now, what about using a 2? Then you would get 5, so you can only add 2 more ones to it. And vice versa, if you take 3 and 1, then you only have 3 left with 2 numbers, so that means 2 and 1. So this is the only combination for having 3 at the start. Now the last one is with 2. How can you get yourself 7 overall if you start with a number 2? Now obviously by this combination up here, by adding a 3, but we don't want this because we already have it. So what we can do is we can then use another number 2. Okay, then we have 4 overall, so we need another 3. This only works with 2 and 1. And those are the only 3 combinations which are are there. And this game might seem like you can construct yourself something totally arbitrary, but it's actually kind of dictated by me, the examiner, basically what you can get out at the very end, at least to a certain extent. Otherwise, it would be a terrible exercise for students in an exam situation, obviously. Now we have those three, and now we have the restriction number 1 done. That's nice. We can strike it through, get it out of my face. Now we can go through the next one, namely the probability of rolling 2 times and getting the sum 5 of the numbers is going to be 1/8. I'm going to call this event just wa, for example. So P of wa, where wa is the sum as being 5, is going to be equal to 1/8. Now we can just go through all of our combinations here, through all of our dice, and see if this even works out. Let us start with the lowest one, 2, 2, 2, 1. Now you can only roll 2 times. Is there a possibility to even get a sum of 5? No, it doesn't work out, obviously, because the highest number you can get is 4. So only 2 are left. Here you can actually get yourself 5 with 4 and 1, or 1 and 4, and here by 3 and 2, or 2 and 3. So we can draw ourselves a few tree diagrams. So we can have on the one hand for this die up here 4 and 1, and after that 1 and 4. Now the probability of rolling a 4 is 1/4, meaning the complementary probability is 3/4 and just the other way around. Those have the same probabilities, so overall we are going to get P of wa, if it would work out, is equal to 2 times 3/4 times 1/4. Now this evaluates to 2, this cancels out with the 16, so 8 is 3/8 overall, and this doesn't work out. Obviously, this is not equal to 1/8. So the only thing left, if possible, if you can even construct the game, this is out in the open, okay? It could work out with this die right here. Now, what about 3, 2, 1, 1? So the only things we can get is a 3 here and a 2 here, or a 2 here and a 3 here. Both have the same probability of 1/4 of rolling it. Meaning overall, we are going to get 1/4 squared, which is 1/16. And 1/16 times 2 is 2/16, which is 1/8. Hey, that does work out very nicely. And this actually restricts our game very much so, because the 2 conditions at the start can only be fulfilled if you use this die exactly. And with the last part, with the expected value, you can go haywire basically. You can come up with infinitely many things you could quite possibly do. Just keep in mind that you always need to pay $1 for you to actually get started into the game. And you can do whatever you wish for actually. What we could do if we were using the number 5 already, let's just say you win a certain amount X. If you let's not use X. You win a certain amount W for win if you roll the number 5, and if you don't roll the number 5, you're not going to get anything at all. So we are going to get ourselves a certain table. Here we are going to have our dollars that you win or lose up here, and here you have the corresponding probability of the thing that you roll. If you roll not a 5, then what you're going to get is nothing, namely you have paid $1. So negative $1 is what you're going to get overall. You're going to lose something. Now, if you were to roll the number 5, then you're going to get a certain amount W. But you have paid $1 previously, so this is W minus 1 that you are going to have overall as a win or lose in some kind of way. Now the probability of getting yourselves to number 5, and this is why I'm using it right now, because we already calculated it, would be 1/8, for example. Meaning the probability to not get a number 5 is going to be 7/8. Okay, and we know that in the long run, the player, it's a legal lottery, but it's a nice legal lottery, because in the long run, the guy who's playing the game is going to win. In the long run, the expected value of X is going to be $2. Now, In order for you to get the expected value, you just multiply those together and then you're going to add those together. So we get -1 times 7/8 and then plus 1/8 times w minus 1. And now we just need to solve this right here. Now this is just -7/8. We can multiply both sides by 8, for example, giving us in the process 16 is equal to -7 plus w minus 1. -7 minus 1 is -8. And adding the 8 to both sides gives us a win to the player of $24 overall. Now, here's how you would basically formulate a sentence at the very end. You construct yourselves the game with the given conditions that we have using this dice right here. This D4 is just a die, not a dice. I'm terribly sorry. This D4 die. Now, what is going to happen is if you roll not the number 5, you are going to get nothing except for losing $1 for getting started with the game. But if you win by rolling the number 5, you're going to get $24 cash as the prize. This is just one of the infinitely many possibilities. We could, for example, also turn this right here around, that you win something if you not roll the number 5 and you lose if you roll the number 5. Now, how is that going to turn out overall? Now we are going to put this little table here once again. If you roll the number 5, it's going to be 1/8, and no 5 is 7/8. This time we're going to win if we do not roll the number 5, so w minus 1 and -1 here. Now, just by intuition, you are going to see, since the probability here is way higher to not roll a number 5, the win also must be lower, obviously, because people are more likely to roll not a number 5 overall. So by just solving this right here, we are going to get back to this stage, but this time the w minus 1 goes over here and we have a -1 here. So that means that 16 is equal to 7 times, and then we have w minus 1 and then -1. We are going to add this on both sides. We are going to get 17 is equal to 7 times w minus 1. Dividing by 7 gives us 17/7 is equal to w minus 1. And adding 1 on both sides, we are going to get that the win that the player is going to get, if he doesn't roll a number 5, is going to be equal to 17/7 plus 1, which is 24/7 overall, which would be bit more than $3.5 roughly, I suppose. And the dollar sign gets to the front for the dollars. That was the wrong way around. I think you probably already corrected me. And as mentioned before, you can go haywire. You can also say, for example, this is just one last version that I'm going to pull out of my R's here. For example, what happens if you roll, for example, let's go with prime numbers, because there are 2 prime numbers in here, 3 and 2. If you, for example, roll a prime number, you are going to get, I don't know, let's make it a bit better. For each and every prime number that you roll, you are going to get $5. So there are 2 possibilities. Actually 3 possibilities, because it's for each and every prime number that you roll. You can have a prime or no prime at all. If you have a prime, then you can roll a prime once again, or no prime at all. Or if you have no prime, then you can roll yourself a prime or no prime at all. So there are 3 possibilities. And the cool thing is they are all distributed 1/2, because we have 2 out of 4 are primes and 2 out of 4 are no primes. So this right here is just a binomial distribution, basically, with a hit and no hit, basically. And now we can, what did I say? $5 each and every time you roll a prime, for example. Now let's just go through the process. We can have either 1 prime, we can have 2 primes, or we can have no primes at all. So let's put it like this. If we have 0 primes, then you are going to lose $1, obviously, by getting started, but you also need to lose some more, or you are going to win something. I'm going to call it W once again, because we don't know what happens if you don't roll a prime at all. If you have 1 prime, then the probability is 1/4 plus 1/4 is going to be 1/2. No primes at all are gonna be just 1/4. So meaning this must also be 1/4 for 2 primes. Okay, for 1 prime, you are going to invest $1 and you are going to get $5, so $4 overall. And for 2 primes, you are going to win $10, but you have to give 1 away, so 9 here. Okay, and now we can just get our expected value once again. So 2 is equal to 1/4 times W minus 1 plus 1/2 times 4 plus 9 times 1/4. This is what you're going to expect. Multiplying both sides by 4 gives us that 8 is equal to W minus 1. This right here times 2 is going to be equal to 8. So plus 8 plus 9. This right here is going to evaluate to 16. So subtracting 16 here is going to give us that the thing that you are going to get if you don't roll a prime at all is going to be -8. So actually this time, if you don't roll a prime at all, you have to pay $8 additionally because you are a fucking loser. And if you roll 1 prime or 2 primes, you are going to get $5 for each and every prime that you rolled. But here is no rule included what happens if you roll 1 prime, for example, and no prime here, so meaning you don't lose anything. As mentioned before, there are infinitely many ways to construct yourself a game like this. And I thought this is a pretty cool exercise, but my students didn't think so. They hated this exercise because they didn't know really what to do. It was so open, yet that was the point of the exercise. But maybe they would have been better off if they would have checked out the contents of today's sponsor, Brilliant. Probabilities. Not so much my cup of tea, but it has to be done, and probabilities can also be cool. Especially if you get into higher mathematics and you notice that all of probability theory is just applied analysis. And this is what I really like, the analysis part of stochastics. And the cool thing about it is that you can visualize a bunch of stuff very easily to get a better understanding of the underlying mathematics and the abstract things that really makes stochastics as difficult as it actually is. And this is where Brilliant could come in. If you are not the abstract learner, the guy who takes a theorem and thinks to himself, well, that is pretty cool, I can probably use it. If you are more of a visualized guy who loves to play around with graphics and interactive stuff, then the contents over on Brilliant, their website or their app, are definitely the perfect fit for you. Brilliant, with their nearly 70 interactive courses in all topics STEM, be it the mathematics that we did today, physics, computer science, chemistry, is the perfect source to get started in all topics STEM that you can quite possibly think of. The ones that I mentioned just now, or maybe even other stuff. Back in the days, they also had philosophy and the like. Point is, Brilliant does a really good job at transferring the knowledge over to their users. They take visualizations and graphics and make abstract concepts way more tangible for the people who use their services. It's seriously amazing, and you should just give it a shot for yourself. Just look at all those graphics and things that I'm putting up here on the screen at all times. It's just absolutely magical, and especially if you are a beginner in a field. For example, you want to learn something about more abstract stochastics like Markov chains. They are definitely the perfect source to get started with your new studies. So what you should do now is you should not take my word for it. You should go over to Brilliant and use my link at the top of the description, brilliant.org/flammable, to get a 30-day free trial of amazing awesomeness. It's completely free. You can also use my QR code somewhere up here in the corner. Try out the whole landscape of Brilliant for completely free. And if you feel like this could turn into a long-term relationship between you and the services, then definitely make complete use of the link and get 20% off an annual premium subscription, which is an amazing deal. They have so much to offer, so much knowledge packed into one website and app. It's just absolutely magical. Check it out and support the channel this way. And I thank you guys for watching. I hope you did enjoy what you have seen today. And up until the next video, I wish you guys a flammable day. The advent calendar is right around the corner, by the way. See ya.